Hello everyone. We'll study one new topic of physics with respect to thermal expansion. So let us see what is the topic. So today we are going to study about a topic called thermal stress. So thermal stress. In order to understand this thermal stress, let me start this video or this particular class with an illustration. Let me consider if there is two fixed points are there, point A and point B. Between these two fixed points, if a metal rod has been connected, between these two fixed points, if a metal rod has been connected, then let me subject this metal rod to some high temperature. If it is subjected to some high temperature, we know that the thermal expansion takes place here with respect to length. If it has been subjected to high temperature, to heat energy, then the thermal expansion takes place in this particular concept of a metal rod. So what actually happens whenever you subject any of the metal rod or any of metal rod, then due to the increase in temperature, the length of that particular rod will expand. That increase in length, we call it as an linear expansion. If there is no space for the metal rod to expand, if there is no area for the metal rod to expand, then definitely the metal rod will get a bend. It will bend in its length. If the bend takes place, it looks like this. If the bend happens in the metal rod, then it looks like this. So if there is no space for this metal rod to expand, then the bend will happen in the middle of this one. So this bend will create an arc at this middle. So this is what happens with respect to the linear expansion whenever there is no space for this one, for expansion. Okay, fine. If there is no space for the metal rod to expand, then definitely the metal rod will get subjected to a huge amount of stress, a huge amount of force will be developed in that particular metal rod, and that stress we call it as an thermal stress. That stress we call it as an thermal stress. And we know that the thermal expansion, the formula for thermal expansion has been given as one type of thermal expansion, that is linear expansion. The formula for this linear expansion has been given as LT, that is the length of a rod after heating, is equal to original length of a rod, that is before heating, times 1 plus alpha delta T. 1 plus alpha delta T. That is the linear expansion is nothing else but it is an expansion of a material or a substance in terms of length whenever it is subjected to high temperature. So this equation can also be written as delta L is equal to L times alpha delta T. It can also be written as delta L is equal to L times alpha delta T. Then the same equation can also be written as delta L by L is equal to longitudinal stress. It is also called as a longitudinal strain, that is equal to alpha delta T. So this longitudinal strain formula is equal to alpha delta T. So now we know that what is meant by Young's modulus. The Young's modulus formula is written as stress by strain. The Young's modulus formula is written as stress by strain. So what is stress here? Stress is nothing else but the amount of pressure which is being developed in that particular rod. So we know the formula of strain. The formula of stress is equal to Young's modulus is equal to stress by strain. The stress formula is equal to force per area divided by strain. The formula of longitudinal strain is delta L by L. Delta is equal to delta L by L. So now if I rewrite this formula, it looks like F times of L by A times of delta L. So now Young's modulus formula is equal to Y equal to F times of L by A times of delta L. This is a formula for Young's modulus with respect to this particular concept. Now if you want to write the formula, or if you want to see what amount of force has been produced in this metallic rod, then the force formula or the amount of force which is being developed in the metallic rod is being given by the amount of force which is developed in this metallic rod is being given by Young's modulus into A into delta L by L. So this is the amount of force which has been produced in the metallic rod, and this is a Young's modulus of that particular metallic rod. So thermal stress is nothing else but it is the amount of force or the amount of pressure which has been developed in any of the metallic rod if no expansion of that particular rod is being done. If the thermal expansion of the rod is not being made to happen, then a stress has been developed, and that stress we call it as a thermal stress. So these are the concepts or conceptual equations regarding the thermal stress. I hope you all have understood what is meant by thermal stress. Thank you everyone for listening to this class.